All right, again, we're taking the limit as n approaches infinity of the sum from k equals 1 to n of delta x times f of x sub k. So delta x, we're taking b minus a over n. So 3 minus 1 over n, we get 2 over n. X sub k, that's going to be a plus k times delta x. So our a is 1 plus k times delta x is 2 over n. So 2 over n going in for our delta x. And 1 plus k times 2 over n is going in for x sub k, which really means we're taking that and putting it in to our function for x. So we're going to have the limit as n approaches infinity of the sum from k equals 1 to n of 2 over n times f of x sub k. So we're taking this whole thing. Oops, kind of lost the 1 there. And we're putting it in for x. So we have that whole thing, 1 plus, right, that's 2 over n k squared plus 1. Right? It's just taking the place of our x right there. All right, so here comes some algebra. I know it's kind of a pain to write this limit as n approaches infinity in front of everything, but a lot of times people end up forgetting to do that at the very end. So I'm going to keep doing it. So we have 2 over n times, we're going to square that whole thing. So we end up getting 1 plus 4 over n k plus 4 over n squared times k squared, and then we have our plus 1 there at the end. So limit as n approaches infinity of the sum from k equals 1 to n of, well, we're going to distribute that 2 over n to everything, but really we've got 1 plus 1. So 2 over n times 2, that's going to give us 4 over n, plus 2 times 4, we're going to get 8 over n squared times k, plus 8 over n cubed times k, oops, k squared. So now I'm going to go ahead and split this up. I didn't on the last one, but I think maybe it's better for people to see it this way. We're going to take the limit as n approaches infinity of the sum of each of these. So the sum from k equals 1 to n of 4 over n plus, remember n's a constant, so that 8 over n squared is like a constant. I can pull that out in front. So we've got the sum of k, the one we have a formula for, plus 8 over n cubed times the sum of k squared from k equals 1 to n. So when we look at this, first one is the sum of a constant. We've talked about this. We talked about it first on Friday. The sum of a constant is just the constant times the number of terms. So in this case, we're doing it in general, so that's just times n. Plus, you know what, I'm going to lose space here. Move this down. Plus, the 8 over n squared, our constant stays out in front. The sum of k, there's a formula we talked about, that's n times n plus 1 all over 2. Plus 8 over n cubed times the sum of k squared is n times n plus 1 times 2n plus 1 all over 6. So those formulas are needed for these types of problems. Okay, So a little simplifying, n's cancel out. 8 over 2, we get 4 over 1. This n cancels out with one of these. Over here, this n's going to cancel out with one of those, so that's just an n squared. 8 over 6, it's like 4 over 3. So for this one, we just end up getting 4. Here, we can distribute the 4 to both of these terms, so we end up with 4n plus 4 all over n, plus over here, I'm actually going to distribute this using FOIL first, and write it off to the side, 2n squared plus 2n plus n, so 3n plus 1. And remember, we had a 4 up top here, so I'm going to distribute that 4 to each of these. So we get 8n squared plus 12n plus 4 all over 3 times n squared. This is where we can split these up. I'm going to take each term divided by the bottom term, so we have the limit as n approaches infinity of 4 plus 4n over n, that's just going to be 4, plus 4 over n, plus the 8n squared over 3n squared, the n squareds cancel out, so we're left with 8 thirds, plus 12n over 3n squared, we're left with 4 over n, plus 4 over 3n squared. So here, if we take the limit as n approaches infinity, all the ones that are constants, 4, 4, 8 thirds, those are all just going to stay constants. The ones that have an n in the bottom, those are going to be 0. So we have 8 plus 8 thirds, so that comes out to be 32 thirds.